Hello, class. Sorry about yesterday. So I had a really heavy migraine, and I'm all okay now. Thanks for your messages on the Google Classroom. From yesterday's work, I'm just going to completely scratch that, and whatever that I'm posting up for you today will be due by 11:59 p.m. Now, there are a couple of special announcements that I need to make first. Our last class essentially will be June 2nd. The June 2nd will be your math um, final. Okay, I will also post this on Google Classroom as well. Before June 2nd, that previous week, what we're going to do is we're going to go over all the things that's covered in the finals, and I'm going to give you review works based on that. Which means, practically speaking, today is May 14th, and we'll be talking about tangent graphs. Next week, starting from the 18th, we'll be starting, also talking about tangent graphs and just wrapping up the entire, trigonometric function graphing. Most likely, what we'll be able to do also is cosecant graphs, secant graphs, and cotangent graphs, just to have you guys just understand those. The week that's starting from the 25th is a Memorial Day, so we won't be meeting that time. So 26, 27, 28, 29, and 30. Actually, these 4 days would be your review days. And June 2nd is on Tuesday. The Tuesday after that, that's when you're going to be taking your math final. Now on June 1st, you will have your ELA. So your ELA testing will be on there. Not anything new will be given to you on June 1st. Maybe I'll go over the answers on the review packet or something on June 1st, and you guys can all just check the answers with me. And that's pretty much the plan for the rest of the month and the rest of the year. Okay. It's very unfortunate that we cannot meet and greet and say our goodbyes there, and also your graduation. I don't know what's going to happen. For math class, that's the plan. After June 2nd, June 3rd, June 4th, and June 5th, I believe there is no test on June 5th, but you have your science and social studies final exam as well. Your teacher, your science teacher and your social studies teacher should tell you regarding to those regards. Okay? If you have any particular questions about anything else regarding the this month, you can just send me an email and then we'll just talk it there. Okay. So first, let's talk about tangent graphs. Now we're gonna be starting from scratch. This is the last trig function, the original trio. The OG of the trig functions are sine, cosine, and tangent. We have mastered sine and cosine up to a point where we can really just, give you any period, frequency, amplitude, and you guys can just do any of that. Tangent graphs are kind of, kind of a little bit easier in a way because it's not as intricate as sine and cosine. That is my personal opinion. Okay. Now, for tangent graphs, what you guys need to understand is that it's going to have a lot of asymptotes. What are asymptotes? Well, they're imaginary lines that graph touches, graph meets up to, but never touches. Okay, so you have a lot of what we call vertical asymptotes. Okay, and then you'll see why. Tangent of x is same thing as saying sine of x over cosine of x. Now, whenever cosine of x is equal to a 0, because remember, both of these trig functions alternate among 0, 1, and -1, right? These three are the main max, mid, and min. But what happens when cosine of x turns out to be a 0? Well, no matter what sine of x is, usually when cosine of x is 0, your sine of x is either 1 or -1. This type of fraction, we call that undefined. or in most cases, we call it infinite because 1 divided by a very, very small number will give you a very, very big number. So whenever cosine of x turns out to be a 0, you want to label those values as asymptotes, okay? So first, what I'm going to do is I'm going to go back to my original pi over 2, pi, 3 pi over 2, 2 pi, and then 5 pi over 2. So every increment will be pi over 2, just like before, right? Negative, and then negative 2 pi, and then negative 5 pi over 2. Okay, so we have the increment set up. When is cosine of x equal to 0? Well, let's graph the original cosine function. You start at 0, you go to 0, minimum, middle, and maximum. So you have this graph that looks like this. That's your cosine of x. Now notice, where is the 0? Where is the 0? Okay, so the zeros happen here, 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 and here. Well, also at 5 pi over 2s, but pretty much essentially it happens every pi increments, right? Between every pi increments, it happens. So what you want to do is for your new period, actually for tangent, it's always going to be pi. If sine and cosine original period was 2 pi's each, tangent graphs is actually pi. So this is actually what's different about tangent graphs. And now each increment was pi divided by 4. And we have talked about how we make each increment to be divided by 4s. Yes, you could do it that way. Honestly, it does not matter. And I'll prove it, and I'll show you why that is. Okay? Now frequency here is 1, so we don't really have to worry about these two at the moment. Now let's talk about amplitude. I need you guys to remember this next time. Amplitude for tangent graphs, it doesn't have one. Amplitude for tangent graphs, you guys will never have one. You don't say it's 1, you don't say it's 2. It's just simply we don't talk about it. Why? Because for tangent graphs, the way that it's structured, the graph, what it's going to look like, it goes up to infinity and negative infinity. There is no middle line where you have from the distance from the middle to top, middle to the bottom. It's not finite value. It's an infinite value. So we just simply have nothing to put for amplitude. That's already 3 things scratched out from the things I always ask you to do. Phase shift and vertical shift is not part of this graph, so we're going to scratch that as well. Okay, so it seems like we have pretty much the new period is pi that's different. And for every single one of these pi's over 2's, or every pi increment, you have what we call an asymptotes. So I'm going to go in exactly to that. For asymptotes, I'm going to graph a vertical asymptote where every single those blue circles, I'm going to draw a dashed line. So for tangent graphs, what you're going to do is you're going to plot a lot of these dashed lines. Okay? Now, think about what happens. I'm going to erase this red line here. Think about what happens at this value when x is equal to 0. What is tangent of 0? Tangent of 0 simply turns out to be actually 0. Because if sine of 0, cosine of 0, that is 0 and this is 1. So 0 over 1 is just 0. So we actually go through the origin. And the way that the tangent graph always looks like, now this is the fun part in which I like to do. Between every single one of these 2 asymptotes, you're going to draw a bunch of waves, in a way. Okay, so what I mean by that is, you're going to start from the bottom and you're going to end up at the top. So you're going to draw a wave that looks like this. That's the center, a wave that looks like that. And if you were to really actually go and graph a tangent, it will look like this on Desmos or your graphing calculator or anywhere. This is your original tangent graphs. Notice how if we were to call this your midline, there is no amplitude. There is none because it goes all the way to infinity. So that's why for amplitudes for tangent graphs, we say it does not exist. Just put does not exist and you can just move on. Okay, so this is the main tangent graph graphs that I would like you guys to understand. So if I ever give you a question like this, let's say 2 tangent of x, even for amplitude, do not put in a 2, say does not exist. The amplitude for tangent graph simply does not exist. And this right here, what it's actually going to do though, is that it's going to reach the y values quickly. So even if you were to set up those two asymptotes at negative pi over 2, pi over 2, and just graph it this way, if this was your regular tangent of x, a 2 tangent of x will probably look like, it will look more like slanted, it will look more slanted that way. Like it would reach the y values quicker. It will go down quickly and it will go up quickly. But that's only depending on how well you set up the formatting of your y, which does not matter at this point because it goes all the way to infinity and negative infinity. So I will not be checking for how great of this thing that you have taken account for. All I need to see is bunch of waves that is correctly in the given boundaries. Draw the asymptotes. That is the most important thing for tangent graphs. Is draw a bunch of asymptotes and draw a bunch of waves between them. Okay. Now, for your homework today, I want you guys to actually draw the tangent graph on your own on a graphing, like say paper. I'm gonna give you the exact same thing. If you want to copy it down, fine. But I'm also gonna give you a question where you do it vertical shifts downwards. Okay. This I'm not gonna tell you how to do because you guys should know what a vertical shift would be, and I need you guys to try that on your own. You guys will do those 2 questions for today. Thank you. Have a good day.